There is something wrong with the universe, and nobody really knows what it means at the moment. The James Webb Space Telescope has certainly discovered galaxies that theoretically existed before the Big Bang. This calls into question the Big Bang theory and our entire cosmology to date. Science is now faced with a seemingly unsolvable problem. Although researchers such as the Swiss physicist Fritz Zwicky already knew of alternative explanations for our universe 100 years ago, it is precisely these ideas that are now becoming topical again. Hardly any school children today know the name Fritz Zwicky, but we do know names such as Albert Einstein, Georges Lemaitre, and Edwin Hubble. These are the researchers whose theories laid the foundation of our cosmology for almost 100 years. Albert Einstein described space-time, Lemaitre came up with the Big Bang, and Hubble observed the apparent expansion of the universe. But now, all these theories are being put to the test, and the new superstar among telescopes is responsible for this, the James Webb Space Telescope. This marvel of technology has given us so many fascinating images of a previously unknown universe that we now know the old theories can only be wrong or at least incomplete. Fritz Zwicky was a contemporary of these great researchers. The Swiss physicist, who also studied the movement of galaxies and the dynamics of the cosmos, came up with a theory that is once again topical and the subject of heated debate today. The idea of tired light is very simple. Zwicky postulated that light is not constant as Einstein claimed, but that it undergoes a physical change during its journey through time and space, which he called fatigue. Einstein said that nothing travels faster than light and that the speed of light is always constant and does not behave relatively like all other known forces in the universe. It seems logical that researchers have long used light and the speed of light as the great benchmarks for exploring the universe and determining such important values as distances and the rate of expansion. But before we look at the possible flaws in these theories, let's take a look at some of the fascinating galaxies discovered by the Webb telescope. Galaxies that are absolutely impossible with its ultrafine sensors. The Webb telescope looks further back in time than any other telescope before it. Thanks to redshift spectroscopy, Webb can detect light that is very small and very shifted into the red. The first deep image of the universe showed galaxies that existed in an epoch 13.6 billion years ago. The amazing thing was that no galaxies actually existed at that time according to the Big Bang theory. It all started with the astonishing discovery by Harvard student Rohin Naidu. He and his team announced the discovery of galaxy Z13, a galaxy that demonstrably existed around 200 million years after the assumed Big Bang. Its age already suggested at the beginning of the Webb era that galaxies could have evolved faster and earlier than previously assumed. However, some researchers did not believe this at first. Then GN-Z11 followed, and with an estimated age of 13.4 billion years, this galaxy once again provided overwhelming proof that the old theories are no longer tenable. GN-Z11 is one of the most distant known objects in the universe and was originally discovered by the Hubble Space Telescope. The discovery was only confirmed by the new Webb telescope. GN-Z11 offers insights into early star formation and galaxy formation in the young universe. Thanks to Webb's stunningly accurate spectrometer analyses, it is currently clear that stars and finished galaxies existed much earlier than previously known. SOURS 93316 was discovered by the Cosmic Evolution Early Release Science Survey. This galaxy was originally estimated to be an incredible 13.8 billion years old, which has sparked enthusiasm among some researchers and brought others to the barricades. The other galaxies still allowed for ideas of a much faster evolution of matter. This was, so to speak, the loophole for all the researchers who were only too happy to hold on to the Big Bang. A galaxy that is just as old as the Big Bang blows up this picture and makes new approaches, such as the eternal universe or Zwicky's theory of tired light, more likely. The age of SOURS 93316 is still the subject of heated debate, with the discoverers constantly presenting new evidence for the authenticity of the find and critics attempting to refute this evidence. HD1 is another unusual galaxy and has an estimated age of 13.5 billion years. It is one of the most luminous galaxies among the very old galaxies discovered so far, indicating an unusually high rate of star formation. These are the facts that scientists are looking for because HD1 could help us to significantly deepen our understanding of the conditions and processes in the universe during this early period. Let's take another look at MAX 0647JD. It is not one of the more unknown newly discovered galaxies, but it still has some interesting features. MAX 0647JD was discovered by gravitational lensing with the Hubble Space Telescope and then further studied with the Webb telescope. With an estimated age of 13.3 billion years, MAX 0647JD is not one of the oldest galaxies, but strangely, it is one of the most evolved. It only existed 500 million years after the Big Bang, but shows such a high degree of order in size that this galaxy should actually be several billion years old. This means that the time of formation of this galaxy would also have been before the Big Bang, which cannot be the case. These galaxies are only 5 of 15 confirmed impossible galaxies, and there are more and more. Tired light, Zwicky already knew it 100 years ago. Imagine the most crucial component that scientists have used to study the universe has been misunderstood until now. Light is not constant but becomes tired over time. Minimal differences are enough to change distances of several million light-years in such a way that our measurements are completely wrong. Another possibility within this theory is that light physically behaved completely differently 13 billion years ago. You have to imagine that the light that now hits the observation mirrors of the Webb telescope was emitted 13 billion years ago or more by stars that no longer exist. Of course, the Earth did not exist at that time, not even our Sun, and it's very likely that only a small precursor of our galaxy existed. These particles of light, therefore, traveled incredibly far and for an incredibly long time. As the light traveled, space also expanded. If the idea of the expansion of the universe is really true, this expansion could have stretched the light, but we don't know that for sure. We have no way of measuring or investigating the original light. We can only deal with the light that has undergone this extremely long journey. We could also never travel back to the time when the light was created. Despite these hurdles, these faint light signals are actually miraculous. The mysteries of time and space and the journey of light allow us today to study the universe as it was 13.5 billion years ago. This is fantastic. Interpreting the signals is really a bit of a guessing game. Researchers have to take all the fixed known quantities and then derive constants, similarities, and meanings. This is how our theories and explanations are created. In addition to light, there are several other quantities that researchers use to measure and describe space. These are certain phenomena that always behave in the same or coherent way. If it now turns out that this was precisely the mistake, we really are facing a complete reorientation of science. Rendra Gupta is a Canadian researcher who, in 2023, put forward a theory that shows that a small modification of these cosmic constants quickly leads to a much older universe. But not only the age of the cosmos would then change. Variables relating to expansion and origin could also be completely different. Gupta presented a coherent calculation according to which the universe could be 26.7 billion years old. However, he also showed that a further small adjustment would lead to an age of 40 billion years. This would explain in a simple way why we see masses of galaxies in Webb's images that suggest a much older universe. Gupta also considers Zwicky's ideas and shows that the picture of our universe turns 180 degrees when just this one small component of tired light is taken into account. Science can go no further. It is fascinating to observe how the world of science reacts to the new circumstances. One person who is excited about the new findings is U.S. astronomer and astrophysicist Michio Kaku. Kaku is regarded as an exceptional researcher who has written many books to bring the mystery of the universe closer to ordinary people. He enthusiastically explained that the Webb telescope completely reshuffles the cards in science, and Kaku welcomes the changes. He knew for a long time that something couldn't be right. Kaku, in addition to his passion for the visible universe, is a big proponent of quantum physics. Quantum physics and classical physics still don't really go hand in hand, which proves once again that we must have a flaw in the system. Other researchers, such as the project leader of the Webb telescope, John Mather, are sticking to the old theories. Mather told the press that he firmly believes that the Big Bang 13.8 billion years ago was correct and that matter, and therefore galaxies, were formed faster than previously assumed. A third scientific genius whose name is currently being discussed a lot in the press is Sir Roger Penrose. A few years ago, the scientist from Great Britain postulated a cyclical universe in which there is a kind of basic matrix that transports the idea of matter from an old universe into a new one. According to this theory, all information is stored when an old universe dies, and in this way, matter could be quasi-turbo recycled in a new universe, which could lead to a faster formation of stars and galaxies. Penrose's model also predicts that black holes play a crucial role in these cycles. In his model, they are pretty much the last objects or physical entities left behind by an old universe. Some recent studies even suggest that our universe could have been born from a black hole. Ultimately, the discoveries made by the Webb telescope challenge the old theories and pave the way for new ones. Whether it is Zwicky's idea of tired light, a cyclical universe, or an entirely new understanding of cosmic expansion, the debate is far from over. But one thing is certain: our understanding of the universe will never be the same again. The revelations brought forth by the James Webb Space Telescope, JWST, not only question the current cosmological models but also offer a profound opportunity to reassess our understanding of the universe's evolution. As these new observations challenge long-held beliefs, they stimulate an exciting era of scientific inquiry and philosophical reflection. One of the significant implications of JWST's findings is their impact on the concept of cosmic inflation. Inflation theory posits that the universe underwent an exponential expansion in its earliest moments, leading to the homogeneous and isotropic cosmos we observe today. This theory has been a cornerstone of modern cosmology, explaining the uniformity of the cosmic microwave background radiation and the distribution of galaxies. However, if galaxies appeared much earlier than inflation theory predicts, it raises questions about the validity of the inflationary model and suggests the need for a revised framework that can accommodate such early galaxy formation. Moreover, these findings invite us to re-examine the formation of the first stars, known as population 3 stars. According to current theories, these primordial stars were crucial for reionizing the universe and transforming it from a neutral to an ionized state. The discovery of mature galaxies at such an early epoch implies that the first stars and galaxies might have formed and evolved in ways that differ from traditional models. Researchers now face the challenge of reconciling these observations with theories of early stellar evolution and the subsequent impact on the universe's chemical enrichment. Another intriguing aspect of the JWST's discoveries is their potential to reshape our understanding of dark matter and dark energy. Dark matter, an invisible substance that does not emit or interact with electromagnetic radiation, has been postulated to account for the gravitational effects observed in galaxies and galaxy clusters. Dark energy, a mysterious force causing the accelerated expansion of the universe, remains poorly understood. The new observations might provide insights into how these components influence galaxy formation and evolution, or even hint at new physics that could explain the unexpected findings. The JWST's observations also stimulate a rethinking of the hierarchical model of galaxy formation. Traditionally, galaxies were thought to grow through the accumulation of smaller building block structures. The discovery of large, well-formed galaxies at an early age could suggest that galaxy formation was more complex, involving rapid growth phases or alternative processes that allowed for the formation of sizable galaxies earlier than previously thought. Additionally, the data from JWST raises intriguing questions about the role of supermassive black holes in the early universe. These colossal entities, which reside at the centers of most galaxies, are believed to have formed quickly and grown rapidly. The presence of massive galaxies with significant black holes at such early epochs might imply that these black holes played a crucial role in galaxy formation and evolution, potentially influencing the rate at which galaxies grew and evolved. In light of these discoveries, interdisciplinary collaboration is becoming increasingly important. Astronomers, physicists, and cosmologists must work together to integrate new data with theoretical models. This collaboration will be crucial for developing comprehensive explanations that account for the new observations while maintaining consistency with existing knowledge. For instance, combining data from JWST with simulations of galaxy formation and evolution will help to refine our understanding of the early universe and test the viability of various cosmological models. Furthermore, the JWST's findings have implications beyond cosmology. They touch upon fundamental questions about the nature of reality and our place in the universe. As we uncover more about the early universe, we gain insights into the origins of galaxies, stars, and ultimately, the conditions that allowed for the emergence of life. This broader perspective enriches our understanding of the cosmos and highlights the interconnectedness of cosmic events. As researchers continue to analyze the data from JWST, new questions and challenges are likely to arise. The scientific community must remain open to revising theories and embracing new paradigms as we seek to understand the true nature of the universe. The exploration of the cosmos is a dynamic and evolving field, and each discovery brings us one step closer to unraveling the mysteries of the universe. The excitement surrounding these new findings also underscores the importance of continued investment in space exploration and astronomical research. The insights gained from missions like JWST not only advance our knowledge of the universe, but also inspire future generations of scientists and explorers. The quest to understand the cosmos is a testament to human curiosity and ingenuity, and it is through such endeavors that we deepen our appreciation of the universe and our place within it. In summary, the discoveries made by the James Webb Space Telescope are reshaping our understanding of the universe in profound ways. They challenge existing cosmological theories, invite a re-evaluation of fundamental concepts, and open up new avenues for research. As we continue to explore the cosmos, we must remain adaptable and curious, embracing the uncertainties and complexities that come with uncovering the secrets of the universe. The journey of discovery is ongoing, and each new revelation brings us closer to a more complete and nuanced understanding of the cosmos.